Assalamualaikum warahmatullahi wabarakatuh and good day everyone. We are students from UiTM Pasir Gudang pursuing the Diploma in Mechanical Engineering program. Welcome to our workshop project presentation video. In this video, we will present the complete manufacturing process of our workshop project entitled Peristaltic pump. We will begin by explaining the safety equipment and safety techniques applied throughout the machining process. Next, we will explain manufacturing steps process, problem appear and solution in process, and discussion. Before we go further, the group members are Muhammad Irfan bin Suhardi, Muhammad Hafiz bin Osman, Muhammad Azhar bin Sulaiman, and Muhammad Nabil Faiz bin Ardi.
Safety equipment and techniques. Safety equipments. First, safety jacket. A long sleeve safety jacket is worn to protect the body and skin from spark, hot particles, and harmful materials during machining activities. Second, safety glasses must be worn at all times to protect the eyes from flying metal and chips, coolant splash during machining work. Third, safety glove. Safety gloves are used to protect the hands while handling materials, operating machines, and avoiding cuts from sharp edges. Fourth, safety shoes. Steel-toed safety shoes are used to protect the feet from falling objects, heavy materials, and sharp metal chips on the floor. Safety machining techniques. First, lead safety. Always remove the chuck key immediately after tightening the workpiece. The chuck key must never be left in the chuck. Second, emergency awareness. Identify the emergency stop button on each machine before operating it. Third, chip removal. Sharp metal chips should be removed using a brush or hook, not by bare hand. Fourth, secure clamping. Ensure that the workpiece and cutting tools are firmly clamped before starting the machining process.
For manufacturing steps process, there are two parts involved in this workshop project. For the first, the housing casing was manufactured by Hafiz and Azhar, and the rotor bracket was manufactured by Irfan and Nabil Faiz. For the housing casing, first, measure and record the diameter and length of the workpiece. Second, use a lathe machine to remove the unwanted edges of the workpiece. Third, measure and record the new diameter of the workpiece. Then, machine the workpiece on the lathe until it reaches a diameter of 54mm. Next, use a drill bit to make a 14mm through the hole in the workpiece. After that, use a boring operation to enlarge the hole to a diameter of 45mm with a depth of 13mm. Then, use the boring operation again to enlarge the hole to a diameter of 50mm with a depth of 9mm from the surface. Next, use a parting tool to make a marking around the circumference 23mm from the workpiece surface. Use a grinder to cut along the mark line. After that, use a hand saw to separate the workpiece. Use a milling machine to machine the workpiece to a final length of 21mm. Then, use a lathe machine to enlarge the hole on the back side of the workpiece to a diameter of 19mm with a depth of 6mm. Use a 5mm drill to make two holes located 13mm from the center on the surface of the workpiece. Create threads in the holes using a tab. Finally, use a 6mm drill to make two holes at the circumference of the workpiece. Next, for rotor bracket, first, cut the workpiece to 45mm of length and 15mm of width using a saw. Next, smooth the cut edges and surface using a grinder and file. Then, milling the workpiece thickness from 6mm to 4mm. After that, mark the centers of the three holes using a center punch. Next, make 3 holes using drill with a 5mm drill bit. Finally, tap the 2 side holes using an M6x1.0 tap to create the internal threads. After completing the manufacturing of these two parts, assemble both workpiece using 3 bearings, 2 nuts, 1 end nut, 2 washers, 1 L25 countersunk screw, 2 L16 countersunk screws, 2 pen head screws, and silicone rubber. Then, make a testing.
Next, problem and solution. For the first problem is hole position incorrect during drilling. The cause is incorrect marking, high vibration of drilling machine, and workpiece movement. The solution is use accurate marking tools and verify dimension before drilling. Use a center punch to create a starting point. Clamp the workpiece firmly in a vise. The second problem is corrosion risk. Cause is exposure of mild steel to moisture, air, or corrosive environment. The solution is clean and dry the workpiece after machining. Apply anti-rust oil or protective coating or store the workpiece in a dry environment. For the third problem is workpiece was difficult to clamp securely in the chuck during turning. The cause is chuck jaws not adjusted properly or surface contaminated with oil. Solution is clean the chuck jaws and workpiece surface. Next, remove the burrs and ensure the workpiece has a proper gripping surface. Adjust the chuck jaws evenly and tighten securely. For the next problem is workpiece too hot after lathe. The cause is the excessive cutting speed, high fit rate, lack of cutting fluid, and longer cutting time. The solution is allow the workpiece to cool before handling and use heat-resistant glove if necessary. Apply suitable cutting fluid or coolant during machining. For the next problem is rough surface finish. The cause is a dull cutting tool, vibration, or the absence of a good finishing. The solution is use a sharp cutting tool. Next, reduce vibration by securing the workpiece properly. Perform a finishing process and filling the surface. Lastly, cutting tool will out quickly. The cause is insufficient cutting fluid or coolant was used. The cutting tool was dull or not suitable for the workpiece material. The solution is apply cutting fluid or coolant continuously to reduce heat and friction.
So we go to discussion. So in this discussion, we will list down all improvement that can be made. So we go to the first part. We will eliminate manual work, like replace hand saw and manual grinders with an automated lathe parting tools, ensuring clean cut with zero manual labor to avoid any error. Next, we will avoid milling machine step. Face the back side of the workpiece directly on the lathe during the second setup to reach the final 21mm thickness. And add corrosion protection such as WD-40. By adding this thing, we can increase lifespan of mid steel component. Next, we go to the part 2. So for the part 2, we can use center drilling. So from this, we can always use a center drill combination bit after punching. This create a rigid pilot recess, preventing the flexible 5mm drill bit from walking across the flat metal face. Next, we can use mechanical depth stop. Instead of manual testing with a screw head repeatedly, set a rigid mechanical depth stop on the machine spindle. This guarantees a highly repeatable, precise countersink depth. Next is flush fit calibration. From this, we can get accurate control of the countersink angle, ensures the screw head nest completely flush with the milled 4mm top surface without weakening the web. And the last but not least is improve surface finishing through finishing cuts, sanding, or sandblasting.